Hey there, students. We are going to talk about an arithmetic sequence today. And in an arithmetic sequence, the difference between each pair of numbers is the same, and that difference is called the common difference. So here, if we look at this example, we see the numbers 5, 10, 15, and 20, and each of those numbers have a common difference of 5. And so this is an example of an arithmetic sequence. And so for this problem, for these two examples, I want you to write these down in your notes section, and we're going to look at finding the common difference for those two examples. So if we start with the first example, we start with the number 5, and then we go to the number 9, and then to number 13, and then number 17. So our objective here is to determine what is the common difference between these four numbers. And we have to figure out how can we go from the number 5 to the number 9. And since we are increasing in value each time, our common difference is going to be a positive number. So I know that I'm going to add something to 5 to get to 9, and that something is going to be plus 4. Similarly, I have to look at what am I going to add to 9 to go to 13. And I'm going to add 4 again. And what are we going to add to 13 to get to 17? It's going to be 4. So in this case, my common difference for the first example is the number 4. And so we can actually continue this pattern to find every single term after 17. So if I were to add 4 a fourth time, then the next term would be 21. And if I were to add 4 again, then the next term after that would be 25. So let's look at our second example. We're starting with the number 20. That's our first term. The second term is 17, then 14, then 11. And so since we are decreasing in value, now our common difference is going to be a negative number. In this case, we look at what can we subtract. So what can I take away or subtract from 20 to get to 17? And that number is going to be 3. So if I subtract 3 from 20, I'm going to get 17. And if I repeat that process, so if I take 3 away from 17, I get 14. And if I take 3 away from 14, I get 11. And so my common difference here, for example number 2, is I'm subtracting 3 from each term. And so if I want to find all the subsequent terms after 11, I'm just going to subtract 3. So minus 3. That would give me a 8 as my next term, the fifth term. If I subtract 3 again, that would give me 5, and then so on. So for this particular sequence, to find every term after 11, I'm going to subtract 3. Before we move on, I want you to turn to page 119, and I want you to look at number 2 and number 4. And I want you to try and find the next 3 terms for this arithmetic sequence and for this arithmetic sequence as well. Okay, students, let's look at how can we write an equation for an arithmetic sequence. So let's get used to some new notation. We have a sub n, which is the nth term or any term you could be looking for in the sequence. It's equal to a sub 1, which is the first term, plus the quantity n minus 1 times d, which is the common difference. And so m would be the term number. So if I was looking for the 6th term, then as long as I knew the first term and the common difference, I can use this equation to help me find the value of the 6th term. Now we can actually find the value of the 6th term by continuing the pattern. But this formula comes in handy when I want to find, let's say, the 100th term, and I don't want to keep adding that common difference, 100 times just to get to that term that I need. And so we're going to look at how can we simplify that process by utilizing this formula. So in order to write an equation for an arithmetic sequence, we only need 2 bits of information. We only need to know the first term, and we need to be able to find the common difference. All of those things that we have in our example number 3 here, I know the value of the first term, and that's 3. So let's go ahead and write that down. we know that a sub 1 is equal to 3. And then we can pretty easily find the common difference. So if I'm going from 3 to 8, I know that that's increasing by 5. If I'm going from 8 to 13, that is increasing by 5. From 13 to 18, that's increasing by 5. And from 18 to 23, that's also increasing by 5. So I know that my common difference is equal to 5. So now that I have that information, first term is 3, and my common difference is 5, then I can use that information to write myself an equation to help me find every single term in this sequence without having to continue that pattern. So to write my equation, I know that the nth term, a sub n, is equal to the first term, which is 3, plus n minus 1 times 5. Now, I know that this might look a little different to you because we're used to seeing this number in front of the parenthesis, so we can actually move that, which is what I'm going to do. So I'm going to actually write this with the 5 over here and then n minus 1. So that means the same thing. I'm just putting the 5 in front of the parenthesis instead of behind the parenthesis. And so now I can utilize this equation here to find any term in the sequence. I could even use it to find the second term, even though we know the second term is 8. But first, I want to simplify this, which means to reduce the equation or to rewrite it in as small as terms as possible. So hopefully we remember the distributive property, although we haven't done it in a while. If I take that 5 and multiply it by the n, that's 5n. And if I take this 5 and multiply it by the minus 1, it's negative 5. And then I can bring down my 3. And now I want to combine like terms. So this 3 is like the minus 5. And if I get those together, that's going to be negative 2 or minus 2. And then I can bring down my 5n. So the equation that represents this sequence is 5n minus 2. Let's say that we wanted to find the value of the sixth term. Now, we can utilize the sequence to figure that out because it is the next term. So if we were adding 5 before, then we can simply just add 5 again to 23, and we'll have 28, which is our sixth term. But if I wanted to use my equation now down here, I can find the sixth term, so that would be a sub 6, and I know that's going to be 5 times 6 minus 2. So what's 5 times 6? Well, that's 30. And if I subtract 2 from 30, then I know I'm going to have 28. So this number that I was able to find using the equation matches the same number if I were just to continue the pattern in my sequence, in my arithmetic sequence. And so although 6 was pretty easy, if I wanted to, let's say, find the 100th term way out here, then I'm probably more inclined to want to use this formula than to keep adding 5, 95 more times or 94 more times. So on page 120, I want you to write an equation. And so again, this is our formula we're going to use. A sub n equals a sub 1 plus d times the quantity n minus 1. So with number 17 and number 18, I want you to locate the a sub 1, the first term, and the common difference, and then set up your equation, simplify it. And number 18, do the same. Locate your a sub 1, the first term, and also the common difference, and then set up your equation and simplify it. Now, it does say here that I want you to find the 10th term, and so you can either use your equation for that, or you can continue the pattern. So for each of these problems, I want you to find the 10th term. So question mark, what is that? And then over here, what is the 10th term? Question mark. And if you have any questions, I'm here for help. So by all means, please ask.